Hi, I'm Adam from One Commons, and I'm going to be talking to you about Unfurl, which is a new DevOps tool that I've been working on for a little while now. Um, so Unfurl is a tool for managing your deployments and your DevOps infrastructure. I think the easiest way to think about it is to think about how with a build, it's like a build tool. So a build tool looks at your source code and figures out what's changed and then invokes the tools to actually build them, like a compiler or a linker, and creates an application. Unfurl does the same thing, but it's deploying your application into the cloud. So it will look at the dependencies. It creates, you can use a high level declaration, a high level declarative vocabulary to describe your cloud infrastructure and your application infrastructure. And it will invoke the right tools for the particular environment that you need with the right configuration. And it manages your deployments and your infrastructure. Everything is in Git. So whether it's configuration, what tool versions you have, the history of your deployments, and the state of where it's in. That's all stored in Git. And so the basics are, like I mentioned, it's a command line tool. So one of the ideas is that it doesn't rely on any kind of server infrastructure. You don't have to install any agents on what you're on what you're deploying, and that everything is user editable. It's all YAML. There's no database involved. Even the state is in YAML, and everything is stored in Git. And so the idea is that, it's by having Git repositories, you can almost think of it as Git repositories that know how to deploy themselves. And so you can easily include other people's Git repositories, reuse these components. So that in that sense, we're trying to be community driven and build up these components. And it's decentralized in the same way Git is. You don't rely, again, it doesn't rely on any other infrastructure out there. And we're using a standard called Tosca to actually for the most of the YAML vocabulary. I'll talk about that in a second. And like I said, it stores everything in Git, whether it's configuration. It has pretty rich support for secrets. It could either automatically encrypt secrets into your Git repository if you need to, or it can rely on an external secret manager like a HashiCorp Vault. It keeps track of other Git repositories, the state, if they're code repositories, the versions, deployment history. It's all stored in Git. And so, and again, going back to the build tool analogy, we're like the make. So we rely on the other tools to actually do the deployment. So we have fairly deep integration with Terraform and Ansible. You can work with essentially any command line tool, and we will actually, part of the build process, we'll install them at the right version as needed. And the vocabulary has, built-in support for things like Helm and Kubernetes and Docker in particular. Of course, that's pretty ubiquitous now. And so what's the motivation for doing all this? So our vision is like, imagine if, just like you can take source code and you can fork a repository, you can modify the code, you can include other code, and you can republish it, and that's what makes open source great. What if you could do the same thing with live services, live running applications? If you see a website you like, you could just fork it, you can change it, you can push back those changes, someone else could deploy it. And so that's kind of what motivated us and is behind the design of Unfurl, is to make that a reality. And so, but getting back down to why would you use it? What makes it practical today? The basic goals are, one is simplicity. Like I said, you can build the descriptions are high level. So the actual implementations, if they work, everything, obviously things are complicated and you might have to drop into it, but it provides a mechanism to hide a bunch of that complexity. And similarly, those high level descriptions make it flexible so that if you want to swap out different services or even move to a different cloud provider, if you can do that, and it'll figure out what's changed and redeploy it. And so you have this kind of flexibility as the infrastructure and your needs change and grow. And one of the big ideas is to really not have any lock-in. So that's one of the ideas of storing everything in Git, and being able to have cloud independence. So you can design you can design your architecture so that it's not dependent on any particular proprietary cloud APIs, if that's your goal. And so yeah, and just to kind of go a little bit further about this idea of creating a build tool, just like again like make if you're compiling code, is that really if any kind of DevOps infrastructure you're building it deploy, there's no one tool that does everything for you. There's a bunch of different aspects of deploying an application, whether it's building it and packaging it and creating containers, provisioning the actual infrastructure, managing it afterwards. All those things require different tools. And so by having a build tool, we can integrate a bunch of different tools and use the best tools for our needs, and still have a coherent picture of it all. And so just to kind of jump into very, very high level view of how it works. So again, the steps to setting up and using Unfurl. First step is there's a notion of environment. So you can create different environments that you deploy into. And so those environments are generally associated with a particular cloud provider. And they're more than just environment variables. So it could be repositories you're using and what branch you're deploying from, any kind of aspect of things that are going to be dependent on that local environment. So local configurations, again, things like secrets, particular account information that you need to log into different accounts. All those things can be isolated into different environments. And then the next step is to build that model, that YAML model. And again, that's using Tosca. And so those are you building, starting with high level components like here's a compute instance, here's a container, here's a network, and how do you build it? You can build those things, and you build the dependencies. And that dependency graph is basically how it knows what to build and detect changes. And then the implementations are when you connect that model to the tools you have. So you say, when you create or delete, call this Terraform thing. Maybe you define an operation, like a backup operation, some sort of operation you want to run later. You could define that, with using a shell script or Ansible. But anyway, so you implement that model, and then again, everything's stored in Git. So as you deploy, it'll commit those changes back into the Git repository. So you can push them and pull them. You can, obviously, we keep the configuration separate from the actual instances that you're running. And then then finally, now you're in a position where you can share and publish either the particulars of the instance or the configuration, so that people can integrate it into their own versions of the application. And so okay, so now I'm going to jump into a demo to try to make this a little more concrete. So first we'll install Unfurl. It's a Python program, so we can install it using pip. And one thing to note is that it just installed with minimum dependencies. We'll see in a moment how it creates a virtual machine to install all the dependencies. So there's much less of a chance of it conflicting with anything you've currently installed on your system Python. And so now we'll create a home directory. So Unfurl creates a directory, a runtime environment, an isolated runtime environment to manage all its dependencies when it's doing deployments. And so right now it's creating a Python virtual machine that it will use to manage your dependencies when you do deployments. And it also uses ASD at manage command line tools your deployments depend on. Alternatively, you can specify a Docker container to run Unfurl deployments in for additional isolation. So next, we'll create a Unfurl project that represents a particular environment and a particular, say, for cloud account. And so we'll use the Unfurl init, creates a new project, and we'll use the with create environment argument here, parameter, and let's call this testing. And so basically we can use this by creating this project which creates a Git repository can now track a history of all the changes that you make with Unfurl into that particular cloud account. And so we'll use this skeleton. Actually, we'll use this skeleton argument to indicate that we want to use an AWS project skeleton. It just adds sets up a little bit of the configuration for you, the structure you want for the configuration. And so we'll just press init. So now we just created this project. So if we go into it, it's called testing. And so this represents our environment. We can look. You can see it's a Git repository. Let's look at the main Unfurl, the project, the main YAML file, unfurl.yaml, and let's look at that. And so if you look in here, so it's created this environment called testing. Because we use a skeleton, it says that your primary provider is going to be an AWS account. Here is where we can configure it, and we can talk about how these are secret. So I'm not going to put any of this information in here. Let's just use a different, because we'll just use the ones I've already set up because or this is a video. So we won't expose our private keys here. So let's deploy into that testing environment. So what we'll do is we will clone an existing Unfurl project. We have one example, a simple example one on GitHub. And so if you're familiar with Git, the commands here should be recognizable. And we will use the use environment option to tell it that we want to deploy into the environment we already created, the testing project. And so we'll just clone this. So now we just cloned this. So now let's go look inside that project. So if we go in here, there's a template file, the Ensemble template. That's the template that we'll be using for deployment. And you can see at the top of this YAML file, there's some basic inputs that we want that are going to be unique to our Ensemble. So, for example, let's call this the domain you want to deploy onto. FOSDEM.1comments.net. This email, which is for Let's Encrypt. And then we'll just stick with this container image, which is kind of boring, but it's just the Nginx sort of hello world website. And then we want to run on map up to port 80. And so here, what we have here, if we scroll down, so these are the definitions. So we have this compute node type, which here we've extracted away all the sort of details of deploying a virtual machine, a virtual instance. So depending on which cloud provider that we set up, so we set up for AWS, when we're deploying to that, it will load the implementation that knows about AWS, but it'll map to these details. And then you can see here, we have these dependencies that between different nodes. So this one's configured by container service. So what container service does, if you look at the implementation, it's using Terraform to create a cloud init that gets loaded up when the virtual machine is launched, and it will deploy the Docker image that we created, and it'll also, using traffic, put an HTTPS web server in front of it and use Let's Encrypt certificates it needs. And then finally, this DNS will it will have a dependency because we are connecting to the public address of that compute instance. And so when that changes, it will it will deploy that. And so this is using our plugin system. We support Octo DNS, and so which supports nearly every DNS provider out there. And so we could use that to generate a record. And so then it just will output the URL at the bottom. And so we did it. So now we're ready to deploy. And we'll deploy just by typing in Unfurl deploy. It will generate a plan based on the dependencies, what needs to change and be created. So we'll just say yes to the plan. It's using Terraform and Okta DNS in these two nodes, the implementations. And so now when Terraform is running, and it looks like it's creating a compute instance. Let's hope that works. And so and this is just a particular implementation. Okay, it looks like that worked, and now it looks like the DNS worked. And perfect. So now we will see if it deployed with that DNS. It basically is running as we're speaking. It should be Let's Encrypt should be getting a cert, and so we can actually connect to the server. So I'm going to switch screens here. So hold on. Okay, so now we'll go to the site we just deployed. And there it is. It's okay, it's a little anticlimactic, but there we go. Okay, so now that we saw that, I'm going to kind of go over a little bit about go into details about what we just saw in terms of how it's actually come together in the YAML files and how we were doing the processing. So you saw how we typed in unfurl deploy, and the first thing you noticed, we created that home environment, which is this is isolated runtime environment that when you call unfurl deploy, it invokes unfurl again in that environment. It could just be a local configuration, or it could be a Docker container. And so it runs inside that. So you have an isolated environment. And then it executes the plan based on looking at the state of where the ensemble was last left off. And then it will execute the configurations. And then finally, when it's done, it updates the status and commits those changes to Git. And it does that by integrating these different files that we saw a little bit when we were creating the project and then running it and deploying it. And so we remember we edited that ensemble.yaml file, and so that's the main thing where everything is stored, and it has different sections in the YAML that corresponds to different aspects that we need to manage the deployments and the cloud in your cloud infrastructure. So there's an environment, the context that it runs in, that we talked about a little bit earlier, and that's built by merging the project files, the repository that has information about the environment, merging it in with the actual ensemble. Then there's the spec section, which is the model that you're building, the status, which includes the state of what you deployed, and then the lock section, which is what we use for reproducibility. And so we talked about this a little bit, so I'll skip past this quickly. So basically, these are the different components that you can put in those environments. I will go into a little bit more about what Tosca is and how it works. So fundamentally, we talk about these abstractions. So the idea is that you can define these high-level things like, say, I need a compute instance, or I need a Postgres database, or I need to talk to a DNS server. And so you can build a high-level model, which we call the service template. But when you go to deploy it, based on your environment, we look for implementations that meet those environments. So there could be many different options for running Postgres. Obviously, you can use the cloud providers like Amazon's AWS. You can use another third-party service. You can host it yourself. But from the point of view of the service template, they're all Postgres. And the similar with the compute instance, whether it's running a Kubernetes pod or whether you're running a virtual machine, or whether you're just running it locally on your own developer environment, the model stays the same. And so that's one of the things that we're doing, which is pretty unique. And again, so what Tosca is what enables that, the vocabulary. Won't go into too much of the details here, but basically it lets you define these essentially nodes and the relationships between them. And there's abstract concepts, and it sets up what are the requirements what does this node need to be able, this application need, to give a specific example to actually work. It needs to run on a compute instance, it needs to connect to a database, etc. So you can define those here, and then the algorithms, the part of the Tosca protocol, will select the proper actual implementation and specific details around that, and then when it does that, it after it runs, you saw how it created a status section, and so that tells you where actually the state of each of these nodes you created. And so it's high level and abstract. So unlike, say, like Terraform, where your state file is essentially an opaque JSON blob that you really can't edit yourself without breaking things, this is something designed to be editable, developer friendly. You say you deploy it and something's wrong, you could change the state from okay to error, and then next time you deploy, we'll try to repair it based on that state. So one of the things that we're trying to accomplish there. And then finally, the lock section, which records specific, as much as we can, a reproducible state of when what happened with deployment. What were the hashes of the container images what were the commit that the Git repositories were at, what were the exact versions, etc. And so that is what leads us to, again, the final step, which is this idea of creating reproducible ensembles, which, again, so going back to the build analogy, really good build system, you have reproducible builds where if I can two builds will reproduce a binary identically binary artifacts, executables. And so if we can think of that analogy, of course, the cloud applications, cloud services is fundamentally non-deterministic in many ways, but we can start to approach having something that's reproducible if we start with these reproducible artifacts and we create these isolated environments, and then we can define cloud environments that are guaranteed to have a certain set of attributes. And using Unfurl, we have a deterministic deployment process, and we can start to build these applications when they're open source, when you have the transparency around what exactly is in the code and how they're built, is when we can get to this goal we talked about a little bit earlier, of essentially creating a free and open cloud where even though we're running on essentially proprietary cloud infrastructure, these hyperscale providers, we if we can start to deploy these open cloud services that have this transparency that people can fork and reproduce, and they start to build on top of each other, we can essentially build think of it as like an overlay, a free and open cloud overlay on top of the infrastructure that exists out there. And we can start to see the same kind of, vivid things that we saw with open source code, where we can start to have a whole rich ecosystem of cloud services that anyone could share, reuse, and share and collaborate on. Okay, thank you very much.